Hello students, myself Kiran TR. I am here to teach you an interesting and exciting topic in science, electricity. Let's go. The factors on which the resistance of a conductor depends. The resistance of a conductor depends on certain factors. Which are these factors? There are 4 of them. They are length, area, nature of the material, temperature. So these are the 4 factors on which the resistance of a conductor depends. Length, area of cross section, nature of the material, temperature. Now let us see how are they related. First, how is resistance related to length? It is directly proportional. Resistance is directly proportional to length, which means if the length increases, the resistance also increases. If the length decreases, the resistance also decreases. Here, there is a small diagram A and B. From the perspective of length, I need you to tell me the answer which of these options has higher resistance, option A or option B. The answer is option B, as a higher resistance. Why? Because it has more length compared to option A. So we will take this equation R directly proportional to L as the first equation. Second, area of cross section. The resistance of a conductor is inversely proportional to area. That is, R inversely proportional to 1 by A. We will take this as the second equation, which means if the area increases, the resistance will decrease, and if the area decreases, the resistance will increase. Now again we have a small diagram here, A and B. I want you to tell me which of these options from the perspective of area has a higher resistance, option A or option B. The answer is option B, as a higher resistance. Why? Since it has less area. Lesser the area, more the resistance. Third, nature of the material. Let us take example of metal. Metal like chromium, manganese, silver, copper. All these are metals. Non-metals like glass, fluorine, chlorine, iodine. Metals, non-metals. The property, when you take a metal, the inbuilt property of the metal is to allow the current to flow. That is, the resistance of the metals. All these metals are low. Non-metals like fluorine, chlorine, iodine, all these non-metals have higher resistance. That is, non-metals do not allow electric current to flow through them. So the inbuilt characteristic, the inbuilt property that you and I have. Similarly, the materials have inbuilt characteristic. So the resistance also depends upon the nature of the material. So if it is a metal, it has a high resistance, it has a low resistance. If it is a non-metal, it has higher resistance. So it is its inbuilt property. Nature of the material. Next, temperature. The resistance is directly proportional to temperature. If the temperature increases, the resistance also increases. If the temperature decreases, resistance also decreases. Let us take an example that you have taken a piece of iron metal, 2 pieces, and you have placed one piece in cold temperature of South Pole. Cold temperature of South Pole, which has minus temperature, very cold, and the other one you have placed in a very hot desert of plus 50 degrees Celsius and above temperature. Now which of these has high resistance, whether the iron placed in the desert or the iron placed in the cold temperature of the South Pole? It is the iron placed at the desert has a higher resistance because the temperature is high. So the resistance of a conductor also depends upon temperature. More the temperature, more the resistance. Less the temperature, less the resistance. Now using these two equations, if we combine these two equations, equation 1 and equation 2, from 1 and 2 we get R proportional L by A. L on the top, A at the bottom. Now we have to remove this proportional symbol. To remove the proportional symbol, we have to add is equal to symbol and a constant, a proportionality constant, which is called rho or electrical resistivity. So this two things we have to add, is equal to and electrical resistivity, which is called the proportionality constant. So we arrive at the final equation, R is equal to rho L by A. Here in this concept we have learnt three new terms. One, electrical resistivity, rho, which is a constant. Two, length. Three, area. Four, temperature. Mainly three, that is area. Now we will see the SI units of these three things: electrical resistivity, length and area. The first one, electrical resistivity, quantity. The symbol of electrical resistivity is a P kind of symbol, or this is a symbol. SI unit of electrical resistivity is ohm meter. You have to add meter after ohm. Ohm meter, the symbol of ohm meter is ohm meter. Next, length, symbol is capital L, SI unit is meter, symbol is M. Area has two dimensions, one is length and breadth. So meter into meter, meter square. Symbol of area is A, SI unit of area is meter square, symbol is M square. Electrical resistivity. What is electrical resistivity? Electrical resistivity is another inbuilt property of the conductor. How resistance is an inbuilt property of a conductor, electrical resistivity is also the inbuilt property of the conductor, and it varies with temperature. Electrical resistivity varies with temperature. But if you keep the temperature constant, we have the highest electrical resistivity is for insulators. Insulators have the highest electrical resistivity. After insulators, alloys. After alloys, metals. This is called resistivity series. Highest resistivity is insulators, next alloys, next is metals. Insulators like glass, rubber, alloys. Alloys, when two or more metals are mixed together, when two or more metals combine together, they become alloys. So alloys have little higher resistivity when compared to single metal. Metal, silver, copper. This is the resistivity series. The elements, the conductors are arranged in such a way that the highest electrical resistivity comes at the first and then descends to lower, which is called resistivity series. We have learnt in Ohm's law, V is equal to IR. So using that formula, we will solve two important sums. Let us see the first sum. How much current will an electric bulb draw from a 220 volt source? This is question A. If the resistance of the bulb filament is 1200 ohm. In the question B, same question, instead of bulb we have heater, 220 volt remains same, and we have 100 ohm. First thing, we have to round off. Round off wherever you find the numbers. So here we find 220 volt, round that off, and we have here 1200, 100. With that, we will go to the given. Given there are two, A and B. One, voltage remains same, but the resistance for option A is 1200, and for the option B, the resistance is 100 ohm. For the bulb, it is 1200 ohm, and for the heater, it is 100 ohm. What we have to find out? Question mark is how much current? After how much? What we have? Current. So we have to find out I. Current is equal to question mark in both the cases. So here we have V and R. We have to find out I. Which formula we have to use? We have to use the formula from the Ohm's law. V is equal to I into R. We have to find I. So replace, let the I be here. R goes towards the left hand side. Into becomes division. So we have I is equal to V by R. Using this formula, we will now solve the problem. A answer. The formula is I is equal to V by R. V for option A is 220. R for option A is 1200. So now we have to divide these both. First cancel the 0. We are left with 22 and 120. By which number will both 22 and 120 go? By 2. So we have 2 1s are 2 1s are divided by 12. 2 6s are 12. Keep a 0. Keep a 0 as it is. 11 by 60. So now we have to divide 11 by 60. While dividing, we have to divide up to 3 decimals. Take 3 decimals and round it off to 2 decimals. So now 11 and 60, let's divide. 11 is on the top. 11 is getting divided by 60. Here we have 11. 11 is getting divided by 60. So 11 which is on the top has to go inside. 11 is getting divided by 60. Now we can't, 61s is 60, so we can't take 61s, so we have to add a 0. How do we add a 0? Simply we can't add, we have to write 0 point. 110. 62s is 120, so we take 61s 60, remainder 50. Since we have a point, we can take one more 0. 60 10s are 600. 10s are we can't, 9s are 9 6 are 54, 540. We have to go for 8s. 8 6 are 48. We have a 0, keep a 0 here. We'll be left with 20. Subtract it. So 20 we can't, again since we have a point, we can take one more 0. 64s is 240, 24, 6 3s are 18. So we can take by 3. 6 3s are 18. Keep a 0 as it is. Again we have 20. We can stop it here. Since we have 3 decimals. 1, 2, 3. 0.183. 3 is less than 5. 3 is less than 5. So we get the answer 0.18. 0.18. Current. SI unit of current is ampere. 0.18 A is our answer. Now let us do B sum. In B, voltage of heater is 220 volt and the resistance is 100 ohm. So here resistance changes. So we will solve B. I is equal to V by R. 220 remains same voltage, but the resistance is 100 ohm. Cancel. 2 1s are 2 1s are 2 5s are 5 2s are 10. Point again 10 1 0 5 2s are 10. SI unit of current is ampere. 2.2 A. This completes our problem. So the current drawn by bulb is 0.18 ampere. The current drawn by the heater is 2.2 ampere. Here you also will notice the fact higher the resistance, lower the current which is flowing. Here we have 1200 of resistance, ohm of resistance. So more the resistance, lesser the current, 0.18. Here the resistance is less, resistance of heater is less. Since the resistance of heater is less, that is 100 ohm, the current is more. So how to decrease the current? You have to increase the resistance. So that fact is visible in this problem. Now we will move on to next question. The potential difference between the terminals of an electric heater is 60 volt. Electric heater. We have electric heater. The potential difference at the two ends of the electrical heater is 60 volt. When it draws a current of 4 ampere from the source. When 4 ampere of current is drawn, The voltage is 60 volt. Now what current will the heater draw if the potential difference is increased to 20 volt? So using the battery, if we increase the potential difference to 120 volt, what will happen to the current is the question. So let us write the given. First round off. 60 volt is rounded, 4A is rounded, 120 is rounded. So what is given? V is given. How much? 60 volt. I is given. How much? 4 ampere. Now what are they asking us to find is, what current will the heater draw? You have to find out the current. I is equal to question mark. When 60 volt becomes 120 volts. When 60 volts become 120 volts, what is the current it will draw? For 60 volts, it is 4 ampere of current. For 120 volts, how much? This question, we can solve it in two ways. One, MCQ question, where we can get the answer in just 5 seconds. The second way is, we can use solving method, which is little longer than as usual. The second method, the longer method, we use it for 2 mark or 3 mark, 2 mark question basically, and the first one MCQ directly we can do. So let us solve both the methods. First method, we'll go with MCQ. We know that V is directly proportional to I. If V, as much as V increases, I also increases in the same amount. So now V has increased, as doubled. So I will also double. V doubled. That is 2x. So what will happen to I, which implies I also gets doubled, which is equal to 2 into V, 2 into I. So what is the I? 4. So we have 8 ampere. So let us take this as I1, let us take this as I2. I2 is equal to 8 ampere. 2 into I1. So here the voltage is doubled. If the voltage doubles, according to Ohm's law, current also doubles. 4 will become 8. 6. Voltage doubled, current also doubles. 4 2s are 8. Second way, first we have to find out the resistance. We will find out R1. R1 is equal to, R is equal to V by I. V by I1. V is 60. I1 is 4. 4 1s are 4, 20. 4 5s are 20. 15 ohm. We have got 15 ohm. Now we have substitute R1 in the above equation. We have to find out I2. I2 is equal to V by R1. What is V? 120 by R1. 15 8s are. SI unit of current is ampere. 15 8s is 120. So we have 8 ampere. So this is a method where you can solve for 2 mark question. So at last we got 8 ampere. If you love to learn more and need more of these videos, click on the subscribe button and the bell icon next to it. Don't forget to like, comment, share. Love you. See you in the next video.